Good morning, everyone, and welcome to Griffith Observatory and our live coverage of the transit of Mercury. Today is November 11th. Happy Veterans Day to everyone. And we're here up early. Half these folks have been here all night. The other half got here around 5 a.m. so that we could bring you this beautiful astronomical event. So why don't we begin by introducing ourselves. I'm Dr. Laura Danley. I'm the curator of the observatory, of Griffith Observatory. With me is Dr. David Reitzel, our astronomical lecturer, Patrick So, our theater and planetarium programs manager. And so we have just a few minutes before the sun rises. If you're looking at the gray behind you, don't get too, or behind us, don't get too alarmed. We'll talk a little bit about that. But in the few minutes before sunrise, let's take a few minutes just to say, David, can you tell us what a Mercury transit is all about?
Yeah, absolutely. A Mercury Transit is an event where Mercury is going to pass in front of the sun. It's going to cross between the sun and us. So we're going to see a little black speck move across the surface of the sun. Now, of course, don't look at this with your naked eye. It's not safe to do that. You need special protection. And in fact, even if you have those solar glasses, you're probably not going to see much. So now what I like about transits is this is the same thing that those special telescopes that are designed to find planets around other stars are doing. An exoplanet that does a transit in front of its star, the Kepler telescope, found thousands of exoplanets that way. So while you're watching this event today, think about that this is the way that perhaps other species around other stars are looking at events like this and seeing Mercury and Earth cross at the same time if you were in the right spot. So think about that. Anyway, exciting event today that we're going to get to see.
What about these clouds?
Okay, well, this is our famous marine layer that we have in Los Angeles, and it occurs when winds from the Pacific Ocean blow onshore and carry moisture. And we have, of course, a grayed out sky, and at 6:22 the sun will rise, but we're hoping we can get a peek of the sunrise if these clouds thin out. They're only about a few thousand feet high, and hopefully when the air temperature warms up, this marine layer and this fogginess will eventually dissipate, and will bring you some beautiful images of Mercury crossing the face of the sun.
So behind me, we have two telescopes set up and two telescope demonstrators. That's Katie and Geo. Hi, Katie and Geo. Good morning. So the larger telescope allows us to zoom in on the sun and get a close-up view of the silhouette of Mercury, which, as David mentioned, is pretty much just a dot, but still it's kind of fun to see it up close and realize, oh my gosh, that's the planet Mercury. And then the smaller one over by Geo is actually zoomed out, but pointed right to that place on the horizon where the sun is supposed to rise. And so, as Patrick mentioned, we've got a pretty thick layer of the marine layer here, but at some point the sun will start peeking through that thin fog, and actually should make for kind of a dramatic and wonderful image of the sun as and it helps our camera because it'll be naturally dimmed down by the marine layer. So in fact, the small telescope there for our horizon shot doesn't even have a solar filter on it. It's really just stopped down, and we will capture the sun as soon as it is able to be captured, as soon as it peeks through this marine layer. So with that, Matthew, who's at our control bench there, Matthew, if you could get a shot, take the shot through the horizon sunrise camera, and we will move inside to our table. So welcome back everyone to Griffith Observatory and our very foggy sunrise. We are here waiting for the sun to break through the fog so we can see the Mercury Transit that is already in progress. So while we have a moment before the sun shows up and we're watching it very carefully, I'm actually starting to see a few things show up on this image, so we may get something hopefully in the not too distant future. But while we're waiting for the sun to break through, Matthew, if you could switch over to the computer, we'll give a little explanation about what is happening today. So today is, as we mentioned a few minutes ago, the 11th of November, and this is the view of the Mercury Transit from Los Angeles. It is already in progress and has been in progress for about an hour and a half. But the sun isn't up here yet in Los Angeles, so we couldn't have seen the start of it if we had wanted to because we were on the dark side of the Earth in night. But we are now at dawn, and sunrise should be happening, should have happened about a minute ago. And as you can see from this diagram, the little dot of Mercury is going to cross across the face of the sun, and it's going to be about a 4-hour, maybe 3 3/4 hour event. So we will be here all morning. We will watch it. We will gather whatever imagery we can, and then we will be condensing it down to a time lapse so you can watch it all happen in less than a minute rather than a 4-hour video. So keep tuned to our social media feeds. All Space Considered is the name on Twitter, Facebook, and Instagram. And we will be posting that as time goes on. But in the meantime, I have a picture from our front lawn and of our own scale model of the solar system. So there it is laid into the cement. And David, you explained a few minutes ago about what was going on. Can you tell us about that?
Yeah, well, as you can see here in our model, our sun is the little dot in the center of this. The orbit of Mercury is indicated by that inner ellipse, actually. Now imagine if the planet Mercury is right at that label, that it says orbit of Mercury, and let's imagine that Earth is right where it says orbit of Earth. Earth, Mercury, and the sun will all be lined up. And as long as Mercury is not above or below the sun, which today it's not, Mercury will pass across the face of the sun. And that's what we're going to get to see today. Now, this doesn't happen very often. The last one was a few years ago, but the next one's even further off into the future. So this alignment of Mercury, the sun, and Earth is rather special, and that's what we're going to get to see today. We'll watch the disk of Mercury pass across the disk of the sun. So quite an exciting view we're going to get today as soon as this fog lifts. Now Venus, the orbit is labeled there. Venus is not at the right location to get into our shot. We're not going to get photobombed by Venus by any stretch of the imagination. That would really be a very rare event. The Venus transits are even rarer. The next one is still, I forget, over 100 years away. So in any case, this is it's going to be really neat that we get to see Mercury pass in front of the face of the sun today.
I love the idea of a Venus photobomb. Fortunately, we have the celestial mechanics to make predictions. We know exactly where Venus is, and yeah, that's Venus. It would be quite a shock to have Venus photobomb this. Can we go back to our sky shot? Yeah, we're starting to see some lights come through the fog that are lights of buildings in the Los Angeles basin. And then if we could also take a look at the shot through our camera, our wide view of the city. Yep, and if you could pan that up just a little bit so we can see the sky, just kind of give us a little bit of a view. You can see our marine layer and then back down. So you can get a sense of the thickness of it. It's I know that looks pretty socked in, but in fact, it is thinning out overhead even in the 5 minutes we've been live. So we are hopeful that we will have a better view this time than we did last time. Matthew, if you could come back to the laptop, we'll just show one more picture here. of last time, which was May 9th. There's intrepid David Nakamoto, one of our theater techs, and an excellent amateur astronomer who brought us those images of Pluto the same night that the New Horizon the New Horizon spacecraft flew past Pluto. We actually had an image here at Griffith Observatory of Pluto, courtesy David Nakamoto and his telescope. There he is 3 years ago, patiently waiting for the clouds to clear. We all believe that we're going to get the sun quite a bit earlier than we did last time. So if we can go back to our shot through the sunrise telescope, we're just going to let that, we're going to wait just a little bit, take a look at that, watch the clouds thin out some, and we'll be back to join you in just a few minutes. Welcome back to Griffith Observatory, where we're looking at the morning fog that's rolled in off the Pacific Ocean and waiting for it to burn off so we can see the transit of Mercury across the face of the sun already in progress. We do expect it to burn off hopefully somewhat soon, maybe half an hour, 20 to 30 minutes. I'm getting a little high sign from staff over there. It's already clearing up. I see bluish overhead, so we just have to burn off that ground fog because the sunrise, of course, is near the horizon. So while we're waiting for the sun to do its job and bring us the beautiful view, I wanted to ask Patrick to explain why we don't see this every day. Can we go to the laptop, please? Where we left off with our narrative, David Reitzel was explaining to us about the position of Mercury and Earth and how that gives us the transit of Mercury. So now we all know that the Mercury orbit is 88 days. So how come this doesn't happen every 88 days, Patrick?
Well, it's as we see in this representation, Mercury's orbit, that inner one, is actually inclined at 7 degrees with respect to Earth's orbit. And so sometimes Mercury is below the plane of Earth's orbit, and sometimes it's above it. And the alignment has to be just right, as we see right there, where the Earth is directly in line with Mercury and the Sun. So that actual alignment there that you see is corresponds to Mercury crossing the face of the Sun. So it's the point where we see the orbit of Mercury, which is kind of going in the upwards direction. At that particular point, that's called a node. It's in an ascending node, and that point usually occurs in the November period, which usually is within a few days of November 10th. And when Mercury goes to the opposite side of the Sun, and the Earth is also on the opposite side, looking towards, in the same alignment, we have Mercury in a descending node going below the Earth's orbit, and that occurs during May 8th. So this is one of the reasons why we have transits that occur usually in pairs in November and also in May. Now the frequency is kind of several years, and in fact the transit that's occurring right now is the fourth transit of 14 in the 21st century. And the first transit of the 21st century occurred on November 8th in 2006. And then the one after that was May 9th, 2016. And actually, I forgot the earlier one. But this is the fourth transit, which is November 2019. So.
And that we were here for that May transit in 2016, right. And that's when we had all those clouds. But we are, as I say, getting clearer every day. So when is the next transit, and when is the next transit that we can see from the United States?
Okay, well, the next transit after this one is November 13th, 2032, but it's not visible in North America. It's visible in the Eastern Hemisphere, so Europe, Africa, all of Asia, and parts of Australia and New Zealand can see this transit. But the next one visible in North America is May 7th in 2049. So that's a ways ahead.
How old will you be? Okay, never mind. I didn't really mean to ask that question. So this might be your last chance to see one. And by the way, let me remind you, I know David Reitzel mentioned this earlier, never, ever, 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 ever look at the sun without protective eyewear. And even if you do have protective eyewear, that dot on the sun is so little that you won't be able to see it, even with eclipse glasses on. So there is no point to try to look at the sun at this point. And the really only way to do it is to look through telescopes. I know NASA is posting images. We have ours. which we're hoping to get to in just a short little while. So I'd like actually now to go back to our dome camera here. If you can switch over. Hi, good morning again. And part of the reason I wanted to do that was to show off our magnificent telescope behind me. So, and once again, let me just welcome you. This is David Reitzel on the end, Patrick So, myself, and up on the ladder, the intrepid telescope head of all of our telescope programs is Tony Cook on the right, and Colin O'Mara Green, one of our telescope assistants on the left. And this that you are looking at is our historic Zeiss refracting telescope. Refracting meaning it's got a lens in it, not mirrors. That's why it's one of these really long, old-fashioned ones. And gosh, that picture almost makes it look like the telescope sticking out of the slot on the dome. It's not. It's well within the side of the dome. That's how artists sometimes draw it, with the telescope sticking out of the dome, but of course the telescope is always in the dome. So after things clear, we will be tracking the view with that telescope, and looking forward to bringing it to you. We are optimistic that the sun will break through the clouds very shortly, and that we'll be able to share this beautiful transit with you. So for now, we will go back to our picture through our sunrise camera. Doesn't look like much. No, it really doesn't look like much. And so we'll just have to keep waiting and be patient until the sun burns off the fog. So once again, we'll be back shortly, and we'll share more with you when we're back.
Greetings from Griffith Observatory. I'm Dr. David Reitzel, and I've got Patrick So here with me. And we are waiting for the fog to clear here in Los Angeles. We're at Griffith Observatory, and we've got a great view. We're starting to see some blue patches. The sun is something like 6 degrees above the horizon already, but it's pretty well down in there in the fog, as you can see from the shots we've been bringing you. Patrick, what is your view on this, and what can we expect?
Okay, so as the air starts to warm up, some of the fog that we're seeing starts to burn off, and it will the burn off will start increasing, and we should be able to get a peek of the sun through the thick marine layer that we had earlier this morning. But it is looking better than at sunrise, and so hopefully we'll bring you those images of Mercury across the face of the sun as soon as.
Now, the actual process of burning off, that occurs because of what? What does it have to do with temperature and moisture and all the rest? Like, why should we be hopeful?
Well, basically, as the temperature rises, it moves further away from the dew point, which is the point at which water condenses in the atmosphere. So if the temperature is at the dew point, we get very thick clouds. We're socked in. As the temperature begins to rise and rise above the dew point, the further away it is from the dew point, the less chance that water will condense in the atmosphere, and then it will dissipate and burn off.
So this is the same reason why out on a nice clear day where it's clear down below, you'll see a layer of clouds up above you. It's cold enough at that layer to reach the dew point, and that's where you get the cloud.
That's right.
But right now, we are in the dew point down here.
Yeah, very close to
Los
it, yes,
Angeles.
exactly.
So we're just waiting for the sun to warm things up and raise the temperature above that point, which the clouds condense, and then we'll get that view of Mercury. We're already a ways into this transit. It's a long event. It takes Mercury hours to cross the face of the sun, so don't get anxious yet. We will have a view of Mercury crossing the face of the sun until after 10 a.m. Pacific Standard Time, and we expect the sun to burn these clouds off, burn this fog off. We're hoping in the next half hour, perhaps, maybe a little sooner, we're starting to see some blue patches that are closer to the horizon. So hang in there, folks. We're going to go back to some music and show you some more shots of the city and this thick fog that we have for the moment as we wait for it to clear. So thank you all for joining us, and hang in there.
All right, well, here we are at Griffith Observatory outside on our roof looking over the city and watching the skies clear. I know it looks pretty miserable out there, but Jared, if you could come look in this direction, and then you should be able to see some blue right there. In fact, if you pan up, it's kind of getting blue up there. That is unfortunately the west, and the sun is in the east, but that's the direction things are burning off. And so we're going to get this fog out of here pretty soon, we believe, and be able to bring you actual footage of Mercury moving in front of the sun instead of actual footage of clouds over Los Angeles. But while we had a moment, since there's not much else to see, we thought we'd take a second and introduce you to some of our team down here. We've got a bunch of people behind me, so Jared, come on along, let's go talk to these folks. We're first going to stop and visit Katie and Gio, who are both telescope demonstrators here at Griffith Observatory. So before we talk about what's happening here, can you just tell us a little bit about what it means to be a telescope demonstrator? What do you do at Griffith Observatory?
We have the good fortune to have a job where we get to show people the night sky, or in this case, we're going to be showing you Mercury transiting across the surface of the sun. But it's a great opportunity. We get to show people space, teach them about some things. Hopefully they learn something.
So every night at Griffith Observatory, every night that we're open, which is 6 nights a week, Tuesday through Sunday, we have telescopes on the lawn. These guys show you the planets, star clusters, the moon, whatever is out and able to see. And of course, behind us, this will be quite a shot, but Jared, if you just turn right around and pan up, you'll see the dome of our big telescope, our Zeiss Refracting telescope, 12-inch telescope, and that is also open to the public, our historic telescope. So come on back, and so let's ask Gio now. This is Gio. What have we got going on here? What are these two telescopes doing? How are they different? What are you, I know we're waiting for the sun to come out, but while we have a moment, what are we looking at here?
Well, both of them are actually following the trajectory of the sun. So we've pre-programmed them to do so. The idea now is, as soon as we can see the outline of it, we have this one set up with a camera. Oh, there! Oh, sorry.
Yep.
We do have the sun.
Okay, Patrick. No, sorry, Matthew. Can you please switch over to?
Get that one fully aligned.
Okay, and how about this one? Is this one?
One's tracking, but it's with the
The zoomed in.
It's not going to be able to.
Okay.
Get it. It's too dim.
Well, this is pretty exciting. I see the disk of the sun with lots of clouds.
Look at how fun this is.
And
We got it, Gio?
okay, just isn't that the way? We should have come out here to talk to these folks 20 minutes ago. Okay, Matthew, if you're seeing the shot, are you seeing the sun? It's going to go behind a thicker part of the cloud now, but it's now it's disappearing again. This is the way it is around here. Okay, well, it's back. Jared, come on back to me. We'll it just disappeared again behind a little bit of a thicker part of the cloud, but that's all moving, and we're going to get in and out intermittent views of the solar disk. And as soon as we see it again, we will switch over. I can't see it with my eyes anymore. Our telescopes won't be able to see it either. So while we have a moment, we'll come back because these guys are busy at work now trying to get that shot. So let's come and visit some of our other Griffith Observatory staff. Here we have David Pinsky, who's a museum guide. And since we're asking everybody, what does a museum guide do at Griffith Observatory?
We talk to the patrons, interpret the exhibits, and do talks and help out in any way we can.
So David is one of our favorite providers of images to All Space Considered. If you've been watching All Space Considered and watched the pretty pictures portion, almost every month there's a picture from David because he takes such beautiful astronomical images. So what have you got? What's your setup here today?
Well, I basically have a DSLR, which is a regular digital camera, but the telescope becomes the camera lens. So I take the camera lens off and I have an adapter here. And this is a refractor. It uses a lens to collect light, and it puts the light right on the sensor, and I'm able to get some nice images.
Fantastic. That looks like maybe anybody could do that. Is it, if you have the right equipment and the right safety equipment, is this something that, your average kind of photography buff and or telescope buff can figure out?
Yeah. Because it's basically after that, it's just getting the right exposure. Though what you want on really dimmer objects is a good mount so it can track and not move. You want it to follow the image as the Earth rotates and it moves with the sky. For the sun today, I don't need that. The sun is nice and bright, but I have a tracker here. And important, if you ever use a telescope to photograph or even look at the sun, it has to have proper filtering. Otherwise, you could damage your eye or camera.
Yeah, let me underscore that. You will damage your eyes if you look through a telescope at the sun. Never, ever, ever, ever do that. You shouldn't look at the telescope even without look at the sun without a telescope. You should just never look at the sun. You want to protect your eyes, but especially if you have any magnification, because that makes it even more dangerous, more destructive to your eye. So all of our telescopes, whenever we have solar viewing here at Griffith Observatory, David, you want to show our nice little tag? You can always be sure that when you come to Griffith Observatory and look through a telescope that has a tag like that it's going to be safe and ready and observatory approved, which means the people operating it will also have really correct and accurate information for you. So our last visitor down here, we're going to go down the line, and here we have David Nakamoto, who is actually a theater tech. So we've had telescope demonstrators, museum guides, and now a theater tech. So David, as a theater tech, before we get to your setup, what do you do as a theater tech?
I basically run the equipment in the Samuel Ocean Planetarium, making sure that it runs correctly and fixing any problems if and when they do occur. But the equipment's pretty stable now, so we're running some pretty good shows, and hopefully next year we'll have a brand new show. And I've seen it, and I'm pretty jazzed by it.
Fantastic. Now I have to say, I just saw the sun peek out, and then it went away again. But we do have a little bit of a clearing. I don't know, Jared, if you can turn around and take a picture of what the sky looks like over there. That sun is right there in that bright patch there. Ooh, I don't know if it's coming through on your camera there. Okay, so I'll let everyone get back to work capturing their images. And Matthew, if you can switch, let's see, hang on just a second. Katie, is your telescope getting it?
Okay, there it is.
All right, Jared, turn and take a look at the sun. We won't hurt our camera with that. See, it's coming out now. In a minute, it will be too bright for Jared's camera, but all the rest of these have the right equipment. So can we go to a shot, Matthew, and see if we can get a shot of the sun and see if we can find Mercury on there? Oh, just as we went live on this image, it's covered in clouds again. Okay, I see a dot. Does everybody else see a dot? Oh, just went behind a cloud. But in and out of the clouds, the face of the sun is peeking out, and every time I see it, I see the dot of Mercury. We're going to stay on this shot even though it looks quite dark because the clouds are moving in and out. So while we go among our different camera feeds, trying to find a good picture for you. Ah, there it is. There you can see Mercury almost dead center, a little bit high and a little bit left of center, covered up by clouds again. So it's going to be like this for the next little while the clouds roll out, and once things get stabilized and we can stabilize our image on the disk of the sun because we can see it, then there you should get a nice little view. There it is. Anyone see the dot? I do. Yep.
Yeah, every time I get a little glimpse of it, the fog comes back in, the clouds cover it back up again, but this is a good sign, obviously. We expect it to get better and better over the next several minutes. We'll slowly get better and better views of this. And there we go, centering up our image for you folks.
It's remarkable, I think, to watch the clouds move over the face of the sun. That's real time. Clouds are just rolling past the sun. Kind of gives you a sense of how small the sun's disk actually is, so that when we're zoomed in, the clouds look like they're racing past. In the background here, that hum you hear is our clock drive, that permits the telescope to track the motions of the sky as the Earth turns. So hey Matthew. When you switch camera views, let me know which camera we're looking through. This is the sunset camera. Okay. That's the camera, the small one outside that we had set up ready to catch the sun when it rose. And yeah, that is just hand tracked. Because right now, that one has no solar filter. The other telescopes have solar filters on them so that, we're able to look at the very, very bright sun. But we thought that at sunrise, the sun would be dim enough going through all those layers of atmosphere that we did not need a solar filter on that one. So that was our plan. So with the clouds doing most of the filtering of the sun, we are using our unfiltered small, what we're referring to as our sunrise camera, and that does not have a clock drive, does not have tracking on it. We had anticipated just having it at sunrise, but right now it's our best view. And so we'll just be patient with nature while the zephyrs blow and move the clouds out of the way. just heard Tony Cook, our astronomical observer, up at the telescope saying, okay, here we go. And indeed, that coincides with some clouds moving off, so maybe they're starting to see it through their filtered telescope. So we know that this is, oh, there you go. We're getting a nice view there. Again, that is being hand-guided as the sun moves through the sky, and because the sun is so small, if you've ever watched a sunset or a sunrise, you know you can see it move pretty well. You're actually watching the rotation of the Earth. And so to hand guide, you have to keep up with that sun as it races across the sky. So it'll be kind of moving around here as they do it. Oh, must have just had a little bright moment. Okay. Which camera is that? Okay, there's the Zeiss telescope camera. That has filters on it. And where'd that Mercury go? Okay, I think we're checking focus. There it is. Again, just above the center, this time a little bit right of center. It has a different orientation, by the way, our little detail here, but the sunrise camera we were showing, the hand-guided one a few minutes ago, was oriented to be parallel to the horizon. So the horizon would be at the bottom and the sun would rise. The Zeiss telescope is oriented along the ecliptic and what's referred to as an equatorial mount. So the image is rotated compared to the other one. So there we go. So it's a little tricky here adapting to all the changes. It gets a little dark, then we try to open up, get a little more light through, and when it gets too bright, then we have to shut down, close it down. Soon all of these worries will be over because the clouds will be gone, the image will be stable. So right now our team is working very hard to get a stable image of Mercury. I actually like it when the clouds are in front. It looks pretty.
Yeah, I like it when the clouds pass in front too. It's a sign that we're on a planet that has active weather and atmosphere, and we're looking at Mercury that does not have much of an atmosphere, has a little bit of an exosphere that it produces as the sunlight falls upon it. And then of course the sun has an atmosphere as well in the background, has prominences and all sorts of things. This filtered view we're looking at is just dimming the sunlight. We're not doing anything special to it. We're not looking at glowing hydrogen gas or anything like that like we can see here at Griffith Observatory. As the clouds pass in front, it gets a little dimmer. We have to make adjustments to be able to bring that sun back into view if we can. The clouds are a little thick, as you can see there. We're barely having our view of the sun, but outside I can see blue skies up above, and these are just patchy the last bits of fog that's passing in front of us, blocking our view. But we're confident things will keep getting better over the next few minutes.
Very bright in the east. And in fact, I love what you said, David, about enjoying seeing the clouds because it reminds us that we're on a planet with an atmosphere that makes living on Earth and breathing that atmosphere so much better for us. If we didn't have an atmosphere, we'd be toast. So I'm glad we have an atmosphere, and it brings out the point you raised at the very beginning, that this method called the transit method that lets us look at planets outside our solar system as they pass in front of their stars. So we are at the point where we can actually even detect atmospheres on other planets as well. Can you explain that a little bit?
Yeah, we can. As an exoplanet, as they're called, passes in front of their parent star, the starlight has to pass through the exoplanet's atmosphere. And we've actually detected things like water vapor, the presence of clouds in atmospheres of these exoplanets. So we know these other planets around other stars actually have clouds, have weather, have atmospheres, and some of them are actually in that right distance from their star that they can have liquid water on the surface, perhaps. Now, we're not able to detect that yet, but we are going to launch in a little over a year the James Webb Space Telescope, and it will have capabilities if it observes an exoplanet transiting its star, just like we're seeing Mercury transit today. It will have the power to analyze that atmosphere at least for certain exoplanets that are close enough to us. So we're seeing a demonstration of how these transits work when we see these Mercury passing the face of the sun today. That's a method we're going to use to analyze the atmospheres of planets around other stars.
Thank you for that explanation, because won't it be fun when we find an atmosphere out there that's like Earth's?
Yeah, well, the key there is Earth's atmosphere is special. It's not what's called an equilibrium. The oxygen would rapidly react with gases, and it needs to be continually added into the atmosphere to keep it there by the action of plants and algae and the carbon dioxide breathers, the ones that breathe that in and breathe out the atmosphere, or the oxygen for us. So if you find that in an atmosphere of an exoplanet, it would be very exciting and would be a sign perhaps that there's life there on that exoplanet.
So while we have a moment with nothing through our telescopes because a little bank of clouds has come in again, okay, you know what, I'm going to do this quickly anyway because we're still dealing with this in and out business. So if we can go to the laptop, Matthew. Now, as we mentioned, the next one visible from North America is in 2049, but I'm about to show a little video that was created by Phil Plate using SOHO data. I saw it last night and I thought it was kind of cool. So what you're going to see here is a picture from a telescope called the Solar Heliospheric Observatory, Solar O and Heliospheric Observatory, SOHO, launched quite a long time ago. And here it is, and that dot coming in from the left, kind of slowly cruising in, that's Mercury. You'll see the date 11/8, 11/9. That is Mercury as seen from the SOHO telescope as it's coming toward the sun. And now it kind of disappears in the glare of the sun. I'm going to rewind that again. Let's see if we can get that. There we go. So there's Mercury a couple of days ago as it was coming toward the sun as seen through the SOHO telescope. Thank you, Phil, for making that great vid. And now we hope to see it on its next step of the journey as it passes right in front of the sun. So let's head back to a telescope view. Still have our foggy clouds in and out, but we're getting somewhere.
I just want to mention that the Mercury, even though it looks like a speck, it represents about 1/200th of the diameter of the sun. It's something that you really can't see visually, even with eclipse glasses. It's so small, and hence it's best seen through professionally filtered telescopes, such as our feed that we have here. Mercury is, of course, we mentioned earlier, has no atmosphere, and it takes about 88 days to go once around the sun, and it doesn't reflect a lot of light. It has a dark surface like the moon, and reflects just about 6% of the light that it receives from the sun back into space, and without the atmosphere, the sunward temperature is 800 degrees Fahrenheit or 427 degrees centigrade. So that's roasting hot, twice as hot as a pizza oven. But on the shadowed side, the night side, the temperature plummets to 290 degrees Fahrenheit below zero, or minus 180 degrees Celsius. So bone-chilling cold, and that's a result of no atmosphere, no circulation of heat. Mercury has been imaged by various spacecraft, and it's a cratered world, very much like our moon, and even in the poles, it's suspected that the areas of shadowed craters may contain ice, craters that have never been exposed to the sun, kind of similar to the moon's craters in the northern and southern polar regions.
So we've had a little success so far seeing the image of the sun and Mercury across it peering through the clouds. But right now there's a somewhat thick patch crossing in front of the sun. So we're taking a moment to just give you an image of the observatory here. And so you can, it's a beautiful day. It's going to get more beautiful. And we'll come back as soon as we have a good view of the sun to share with you. There we go. There's another image now. Oh, this is just annoying. The minute we get an image, we're inside the dome, and that other telescope is outside. So I was all excited to bring you news of our view. You can still see Mercury. There it goes a little bit brighter. But one thing you don't see on the sun is sunspots. So Patrick, what's up with that? Why aren't we seeing any sunspots?
Well, it just happens that we're in the solar minimum, and we have not seen any sunspots for quite in many months. In fact, at the beginning of this year, there were many days and weeks that went by without very low sunspot activity. That's the point of solar minimum, where the sun is least active in terms of sunspots. Normally, on an average a day that you expect to see sunspots, but not this time, and it's been like that for a few weeks, and we continue to not see many sunspots, and even the ones that we do see are very small compared to ones during an average year.
So Patrick referred to solar minimum. And that implies there's something called solar maximum, and indeed there is. The sun goes through a cycle of variability. It's actually a 22-year cycle, but you often hear it referred to as an 11-year cycle, where it goes from lots of activity, lots of storms, lots of spots and coronal mass ejections, just lots of activity on the sun, and then it calms down and you got nothing, no solar activity, and then it comes back 11 years later. But this time, the polarity of the magnetic field is reversed. So if in the first cycle of 11 years, you have sunspots that are neighboring each other, one has let's say a north pole, and the one that's trailing has a south pole. On the next cycle, the next 11 years, you get pairs of sunspots where the leading will be a south pole and the trailing will be a north pole. And of course, this also depends on the hemisphere of the sun. So the sun is not only the thing that gives us warmth and fun days at the beach and sunburn if we're not careful, but it also makes life possible on Earth. And it is a very complex system all of its own, with its own space weather. So tell us, David, do you want to tell us what happens during a solar maximum? What does that mean for life on Earth? What happens here on Earth?
Sure. The sun during solar maximum, like Laura was saying, is extremely active. So these sunspots are areas where you have a magnetic storm. The magnetic fields get very twisted up, and it holds the material on the surface of the sun in place. But when these magnetic fields finally snap and realign and come back into a more equilibrium state, they release a lot of energy, and you can get what's called a coronal mass ejection off these sites. And in fact, we have a whole planetarium show here about how the interaction of these coronal mass ejections and the Earth's magnetic field lead to something called the aurora that we see here on Earth. So during solar maximum, you often see a lot of aurora borealis, aurora australis. These coronal mass ejections can be somewhat dangerous for things like our power grid. They can come here and interfere with our power lines, interfere with transmissions. Satellites in particular need to be ready for them. So here at solar minimum, although we have a bit of a boring view of the disk of the sun, no sunspots to be seen, it is a bit of a safer time for satellites that are in orbit around Earth, and the sun is rather calm. But at the maximum, high magnetic field activity, coronal mass ejections, you can get flares, which are bright spots on the sun that are associated with these magnetic fields, where it'll glow very brightly for a period of hours. A lot of prominences, which are material that's been lifted off the surface of the sun. You'll see it around the edge of the sun. Here at Griffith Observatory, we have a H-alpha filter. It's a filter that looks at glowing hydrogen gas. And along the edge of the sun, you can actually see these prominences if you come up on a day we're open, where the skies are clear. Today we are closed to the public. If anybody's watching our stream and is thinking about coming up to Griffith Observatory, we are closed on Mondays to do maintenance. And on top of it, it is Veterans Day, and we'd like to say Happy Veterans Day to all the veterans that are out there and to everybody that is celebrating that today. So our view of Mercury isn't too bad right now. You can see the black spot on the disk of the sun. As the camera adjusts itself, as it makes adjustments as those clouds pass in front, you might notice that it's bumping around a little bit. We expect this fog and clouds to continue to lift as the day goes on, and our view will continue to stabilize and get better and better.
Another thing to be concerned about when there's a lot of solar activity is the exposure that astronauts would face traveling outside the protective shield of Earth's magnetic field. You've all seen diagrams of sort of a picture of the globe of the Earth with what looks like the pattern of iron filings around it, you know, that shows the Earth's magnetic field. And that magnetic field protects us from the incoming bombardment of high energy particles that could otherwise be very damaging to our DNA and to life on Earth. So we're very fortunate. One of the important ingredients for a healthy living planet is to have that magnetic shield around it that will allow for a stable, low radiation environment in which life can evolve slowly. So if we're going to leave the protective cocoon of Earth's magnetic field and colonize Mars or colonize the moon or live in colonies in space. I am thinking of the TV show The Expanse, just because if you've watched our shows before, you know I'm a fan. Anyway, all those guys flying all around, living on all those asteroids, everybody's got to be concerned about shielding from magnetic storms, because that radiation can be extremely harmful to our health. It has so much energy, it goes into your cells, rips up your DNA. Your DNA says, wait, what am I coded to do again? What protein am I supposed to be making over here? It doesn't actually say that, but I'm kind of, giving it a voice. And so cells can kind of get a little confused about their instructions and go a little errant there. But not with Earth's protective magnetic field that makes life on Earth stable and possible.
I might want to add with when there is there's activity from the sun, the Earth's atmosphere expands outwards and to high altitudes, and so that presents a problem for orbiting satellites, especially with solar panels, because that increases the drag on the solar panels and will cause satellites to slow down, and they tend to deorbit a lot quicker. Now, in cases like that, during high solar activity, satellites are basically boosted to a high orbit where they don't experience as much drag as they would. During solar minimum, that's not a problem because the atmosphere height is a little bit lower, and so satellites experience less drag and can orbit safely around Earth. We are still seeing some clouds drifting in front of the sun, but Mercury is still there. And
Matthew, our engineer, has just suggested he might try to do a little digital zoom, meaning using the equipment to zoom in on that image, see if we can get a little bit of a better view. There we go. Oh, it's tricky business.
All right, so we have a zoomed up image. It's a little bit more shaky because it's zoomed up and a little bit more magnified, but you can see it, a distinct black dot, and that's the planet Mercury. And it is currently about 110 million kilometers away from Earth, and it is actually at this time closest to the sun. So it takes roughly about 5.5 hours to cross the face of the sun. There are times when Mercury is further away from the sun, and when we experience a transit, being farther away, it slows its orbits a little bit slowly. So in that case, it can take up to 8 hours to cross the face of the sun. Mercury is currently traveling at 57 kilometers per second, its orbital speed around the sun, and that's pretty quick, but bear in mind that Mercury is about 36 million miles away from the sun itself.
Well, I think we will probably put on a little music, take a little break here. We wanted to let you know what was happening with all these images that we're trying to share with you through our different telescopes. Each is optimized in a different way, so we are trying to get the best image for you. And I think we will take a little bit of a break, because very shortly things should stabilize, and we should be able to have just a nice, good, clean, clear, fog-free image of Mercury as it finishes its transit across the face of the sun. So with that, we'll take a little bit of a break from talking with you, and we'll be back in a little while.
Hi, folks. I hope you just noticed that jet fly right across the face of the sun. So Mercury isn't the only thing transiting today. And our crewmate, Jared, is figuring out what that was. It looks like it was an LAX to Boston flight, a Boeing 757. We could tell you the registration serial number, but it's probably more info than you need. But that was Delta Flight 1526 on the way to Boston, a 757. So thank you for that, Jared.
So all those people on that flight on their way to Boston, you're in our live stream. We hope you have a wonderful time in Boston. That was great.
Yeah, if anybody knows anyone that was on that flight, let us know, and we'll send them a little clip of the video, and they can see their plane fly across the sun. So you are watching the live Transit of Mercury event from Griffith Observatory. We're live streaming. We do not have a public event today, so if you're sitting at home thinking, I have a couple of hours, I can get up to Griffith Observatory, don't come up here. You'll be a little disappointed. But do stay tuned into our live stream. If you wish to see this with your own eyes, you do need protection. You must have a properly filtered telescope. It is not safe to look at this. It's not safe to use 10 pairs of sunglasses. They don't provide the proper shielding you need. You really need proper eye protection. And even if you have a pair of eclipse glasses, you probably won't be able to see Mercury. It's a little too small for folks to be able to see just through the eclipse glasses. So you need a proper telescope with the proper solar filter, or you can just stay here tuned into our live stream and you can watch Mercury transit the sun all the way until a little after 10 o'clock today.
And while you're watching it, you've probably noticed we're playing some music in the background. These are cuts from music from our planetarium shows. I believe the one you're listening to most recently is from a show that we no longer show here called Time's Up, and the music is by Michael McQuistion. We were very thrilled with that score. So we'll put up signs from time to time telling you what the music is, but we hope you like this music. For those of you who have seen other streams of our eclipses, you know that we love to share this music with you, so we hope you're enjoying it. And we'll come in from time to time when there's something to update you with, like, oh my gosh, there's an airplane that flew right across the face of the sun. That was crazy. All right. Any other comments from Patrick or David? Okay, I guess not. Oh, good idea. Matthew suggests we tell you about the two different shots that we're cutting back and forth from. One is a full sun image that's being taken through a scope on our historic Zeiss telescope. And so when you're seeing the full image of the sun, that is the one that we're seeing right now, although it looks a little cut off at the bottom, but I'm sure that we'll recenter at some point. And then the zoomed in is a different scope out on our roof deck. We're looking at it now, and it's just zoomed in so you can get a really good look at that dot. And that may seem like, okay, it's a dot, but when you think that it's an entire world all of its own, a planet, we're actually watching Mercury real time cross in its orbit around the sun, and we're seeing it in that portion when it's passing directly along the line of sight between the Earth and Sun. Patrick mentioned earlier that we don't always get that view because Mercury's orbit is tilted about 7 degrees from the Earth's orbit, and so sometimes Mercury is above and sometimes Mercury is below what's called the ecliptic plane, the plane that has Earth's orbit around the Sun. But in May or November, Mercury will cross, it's constantly crossing the ecliptic plane, but you get a lineup of the crossing of Mercury across the sun when the Earth is in the position of May or November. In other words, twice a year we happen to be in the right direction to see what's referred to as the node, that place where Mercury crosses the ecliptic. So when it's July, we're on the other side, and you can't see it because either Mercury is above or below the sun. But in May or November, at this time in history, we're in the right position to see the node of Mercury, and if Mercury happens to be on its node, as it is today, crossing the ecliptic plane, then we see it pass right in front of the sun. So it's not as rare as a transit of Venus, but it's still a rare event, and there are only 14, I think Patrick said earlier, this century. And we won't see another one from North America until 2049, so get your view on here. We won't be able to bring it to you from Griffith Observatory for another, yikes, 30 years. Will I still be here? Anyway, we hope you are enjoying this, and we'll let you just go back and enjoy the music and the view for a little while.
Hi, it is almost at the top of the hour at 9 o'clock here, Pacific Standard Time. We're bringing you live views of the Mercury Transit from Griffith Observatory using our historic 12-inch Zeiss refractor telescope. This is the telescope that on most nights that it's clear and we're open to the public, that's Tuesday through Sunday, people can actually come up here and look through this telescope. We can show all the bright planets that we can see. Saturn is a great view through this telescope, Jupiter. And today, we're bringing you views of Mercury passing across the face of the sun. This is called a transit when this happens. We have a little over an hour left of this Mercury transit that you can enjoy. We have a couple of different views, actually. The main view we've been bringing you is from our Zeiss telescope. We have a zoomed-in view, which is from a telescope out on our roof, and you can see that zoomed in view here. And you can note that the little black silhouette of Mercury is moving closer and closer to the limb of the sun. And if you look carefully, you'll notice that limb is a little bit darker than the center of the sun. This is a real effect. This is known as limb darkening on the sun. As you look in the center of the sun, your line of sight is passing into deeper, hotter layers of the sun. And along the edge, or the limb of the sun, your line of sight never pierces that deep of a layer, and you see cooler layers which don't glow as brightly. And this is an effect known as limb darkening. So enjoy the view of Mercury passing across the face of the sun here. Again, we have about another hour of this that you can enjoy, and we're bringing you music from our planetarium shows. So enjoy this wonderful transit of Mercury, folks. Hi, folks. Griffith Observatory astronomical lecturer Dr. David Reitzel here, and we are watching the last, about 33 minutes of the Mercury transit that we're seeing. Mercury will begin to exit the disk of the sun. It'll hit the limb at 10:03 precisely, and it will exit completely at 10:04:40. 4:43, something that we had just looked it up in the Astronomical Almanac, and that shows how great my memory is these days. That's what happens when I have to wake up at 3:30 in the morning. But it'll take a little over a minute to cross the limb of the sun, and we're about a half hour away from that. So that will be something we're going to want to take a look at. We're providing a couple of different views. One is from the dome of the famous 12-inch Zeiss telescope that we're using the clock drive on it to track the sun. That's the wide view that we have, and we can switch to it here. Take a look at our wide view shot that shows most of the disk of the sun, like so. And we do, of course, have the proper filtering on our telescopes. If you want to see this yourself, you do need to use proper filtering. You can try with eclipse glasses, but unless you have some spectacular eyes, you're not going to see Mercury. It's too small to be seen by most people's vision. Our zoomed-in view is from a telescope we have set up out on our roof, and it provides a slightly zoomed-in view where we can see Mercury approaching the limb of the sun. And like I said, it'll intersect that limb. It'll make the first contact. Actually, that'll be called third contact at that point, I believe, is the nomenclature of these transits. When the edge of Mercury first contacts it, and then a minute and 40-some seconds later, Tony has it here for me, minute and 41.9 seconds is the amount of time it'll take to cross that limb. So we have about a half hour left of our Mercury transit here, folks, so go ahead and enjoy, and we're going to return you to our beautiful music from our planetarium shows and our live view of Mercury transiting the sun.
Welcome back to our Mercury Transit in progress here from Griffith Observatory in our wonderful historic Zeiss telescope dome. We've got a bunch of staff in here all enjoying the Mercury Transit. Now, we had a request from a teacher who is using the footage that we are providing with a student project. And that teacher asked for some, if we could put a UT, which stands for Universal Time timestamp, on the image so they can calculate very precisely where Mercury is according to, synced up with Universal Time clock. So we are going to help that teacher and those students by putting in a little feed here. Go ahead, Matthew, let's see that first one. And that comes from the National Institute of Standards and Technology in Boulder, Colorado. They have a wonderful website. If you just type in NIST, N-I-S-T, which are NIST's initials, and time, that's the first link that comes up. And you can set it to whatever time you like, and it's a lot of fun and it looks great. Also has a little picture of where on Earth it's sunny and where on Earth is dark. But that anyway is universal time. Now there is a second universal time app that our astronomical observer Tony Cook found, and if Matthew, you can bring that up. And we'll see if they're the same. Because, of course, the idea when you're in science is you really want to understand your uncertainties. So if we just put one up, you wouldn't really know, well, is that going to be the same as somebody else's universal time calculator? So this gives you a little bit of a look. My eye shows that one changes a little bit sooner than the other.
Yeah.
But, Tony, would you tell us about the app?
Yeah, so I'm using Occult Flash Tag. It's the name of the app in the App Store, and it's designed really for field astronomy work using video when you need precise timings of video frames. And if we were using it totally the way it's supposed to be, it would actually make your camera flash at a certain pre-agreed upon time. However, it displays an estimated UTC time, and although when we started the National Institute time, they seem to match very closely, but now they're about a second apart from each other, at least the display I'm getting on my phone, with the phone now a second behind the other display. So
Oh, that's odd and interesting. We might have to try this experiment again and see if we put them in at the same time and see how long it takes for them to unsync. We don't want to take away from the visual enjoyment of the transit, so we'll probably, we'll see. We only have actually about 12 minutes, 11 minutes, 11 minutes until the start of egress, and that start of egress means the limb, the little dark edge of Mercury, will hit the edge of the sun. Yeah, David, do you want to explain what that's all about?
Yeah, well, of course, it's going to take some time. Mercury has a physical size. It's about 9 arc seconds across. So the sun is much, much bigger, but that arc of the sun is what we call the limb, and is that little dot of Mercury, the little black spot. When it first makes contact with it, that's when we call the beginning of egress, and that's going to be at 10:03, and it's going to take about a minute and 40 seconds or so for it to completely exit until the far side of Mercury has that last and final contact with the limb of the sun. So we're looking forward to those last moments of this Mercury transit.
And in fact, Tony, maybe you could say a word about the teardrop effect that happens. Or if you don't want to, you don't have to sprung them on.
No, as you notice, the image is swimming a little bit, and that's because of just turbulence in the air. The air is heating up here, so it distorts the image. And that can produce an effect as Mercury gets closer to the sun. It distorts the image so that the dark edge of the sun seems to get pulled into Mercury, and it looks like, it's kind of glued to the edge of the sun for a few seconds before it more obviously is moving off from the sun. So it's just sort of a distortion caused by our atmosphere and the optics of a telescope. combine to make that dark effect.
Great. Yeah, we still have quite a lot of atmosphere. I'm looking out through the door. There's still a lot of ground fog. Fortunately, the sun is out, but there is a big, bright glow in the sky around it that indicates there's quite a bit of moisture and condensation in the atmosphere and a fair bit of turbulence, which you're seeing in the image. So we won't, the best way to do that is to see it from space where you don't have to. But before we remove the time clocks from our image, Matthew, I just wanted to comment. I noticed one says estimated UTC time and the other is from the National Institutes of Standard and Technology. So students out there or anyone who wants to do any timing experiments with this feed of the image, I'm going to recommend that you use the National Institute of Standards and Technology feed. I think that's probably going to be a little bit more accurate.
Although you can actually read, I think they have disclaimers on the accuracy. The phone app actually updates from all available sources that are available to the phone, which are really based on the National Institute time, but they use GPS, for instance, and other very precise timing methods that the phone can access.
And in fact, I should do this before we go, just because the proper thing to do is to see it in a 24-hour clock. I didn't notice I had it at a 12-hour clock earlier. So that's the time UTC. And so you've heard a little discussion here, the battle of the accuracy, which one is better, but it goes to show that there is always a little uncertainty, and you need to calibrate and understand your uncertainties, students. So we hope this has been useful for your project. So with that, I think we can remove the time clock because they'll be able to calculate everything from there. For those listening, our feed is a straight 30 frames per second feed, not the 2997, if that's familiar to anybody out there. So if you're capturing it, we're sending out the stream at 30 frames per second. And that way you can, sounds like I just got a text. So anyway, we have, looks like, only 8 minutes until egress. 7 minutes till the start of egress. And so unless there's anyone who has a comment, we can...
Maybe just for usefulness for the students, we should display the time right after the transit so they can count frames to try to get a more accurate...
You bet. We will do it again at the end of our webcast so that we can see how consistent it is across time. Let's see. I think I will actually take this moment to say that if you have never been to Griffith Observatory before, for all of you who don't live in Los Angeles, we hope that when you come to Los Angeles, you'll come visit Griffith Observatory. And in fact, we hope you'll come to Los Angeles so you can visit Griffith Observatory. It's a good reason to come to Los Angeles because it's just so beautiful here. And as I mentioned earlier, we have telescopes out every night that it's clear and that the observatory is open. The observatory is open Tuesday through Sunday, and we close at 10 o'clock at night. So the telescopes are open until about 9:30, 9:45-ish. And so come look at planets, look at the moon, look at star clusters. There's a lot to see, even though we're in very, very brightly lit Los Angeles. It's amazing what you can still see. I also want to mention that we have a celebration coming up next Saturday. I guess, what is that, the 16th? I think it's the 16th of November, Saturday the 16th, to commemorate and celebrate the 50th anniversary of the Apollo 12 mission. Many of you watching may have seen all of the celebrations and remembrances of the Apollo 11 mission in July, earlier this year, July 2019. But of course, Apollo 11 was just the first mission to land on the moon. Apollo 12, 14, 15, 16, and 17 all landed successfully on the moon. And many of you will remember, and if you're too young, maybe you've seen the movie, of the amazing Apollo 13 mission, which did not land on the moon, had some problems on the way to the moon, and was a really dramatic and scary, frankly, set of circumstances, but of course, spoiler, we brought the astronauts back safely, so all is well. We will be broadcasting several talks next Saturday. If you go to Griffith Observatory's website, you will see a link to the Apollo 12 events, and we will be having an event for each and every Apollo mission all the way through Apollo 17. And you know what? We should also do Apollo Soyuz, I think, which happened in 1975. Yeah. And so we can look back and remember those amazing accomplishments. So looking at my clock, it looks like we've got 4 minutes until the start of egress. Maybe this is another good time to thank some people before we, because we'll probably close out pretty soon afterward. I'm going to do the scary thing and try to do it by name, which means I'm bound to leave somebody out. But
aren't you supposed to start by thanking the Academy?
For this amazing honor. Yes, you can't see, but I'm in my spangly gown over here. So first we'll start with the telescope crew. Tony Cook, our astronomical observer, who's kind of the godfather and central figure of the entire operation, and several of his staff, Gio Somoza, Katie Hogland, and Colin O'Mara Green, all were here doing an amazing job with telescopes, trying to make all that happen. We had additional telescope support from David Nakamoto, telescope theater tech, and David Pinsky, a guide. And on our crew, our technical crew here, as always, our intrepid and wonderful main engineer, Matthew Burlando, sitting over there shaking his head because he hates us to thank him, but we're thanking you. Sorry, Matthew. And Jay is around the corner, I think, and Jared is here, and anyone else from his crew? I don't think so. I think that's it from the theater tech crew. So thank you so much. A special thank you goes to Katie Flynn, who is our production manager. And when we end in just a few minutes, she swings into full action to take the feed from this event and condense it down into a time lapse. Look to our social media sites. In fact, Matthew, if you could put up that lower third with the social media sites. As soon as we've got it all edited together, you will see we'll put out a time lapse of the Mercury Transit from the footage that we have. And so Katie will be busy doing that, and she's also been busy tweeting and posting to our social media. And then finally, a huge thank you to Patrick So and David Reitzel, our planetarium and theater programs manager, and our astronomical lecturer, for joining me here today and getting all of this put together. And there's our social media links. We'll take them down in just a second because we're about to go into egress. So go ahead and take them down, but look for our video. Lastly, I want to thank Friends of the Observatory that supports us in so much that we do. It's a membership organization. Consider joining. And thank you to the City of Los Angeles Department of Recreation and Parks, which is our home. We are a city observatory. We are supported by tax dollars, so we thank you, the tax-paying citizens of Los Angeles, to make all of this possible so we could share the Mercury Transit throughout the world. So Davis, walk us through egress.
Well, it is beginning right now. The limb of Mercury has officially contacted the limb of the sun. It looks like we have a little tiny chunk still of the sun's edge has been taken out. The seeing, which is the stability of the air, how still the pictures are, is not so great. Like we were saying, the sun is heating up the earth, and the hot air is rising. Those are the ripples you see passing, but you can notice there's still a tiny, tiny bite taken out of the sun. And over the next 30 seconds or so, it'll go away completely. And that's how we'll know that Mercury has egressed the sun completely. So we only have maybe 15 or 20 seconds, and I'm not noticing much of a bump left, maybe a little bit right where I know Mercury has been.
You know, I'm looking on this screen, my computer screen. It's still present there in the ripply noise. of the seeing.
Ever so slightly, it is.
But indeed, looking at our official National Institute of Standards and Technology view, it is now 18:04,
Yeah, and there was-
6:04 Universal Time.
And the actual time, according to, I think it ends at 41.
Yeah, I still see it here. I would just was like, hey, wait.
So we have another 30 seconds or so.
So we'll celebrate the last 15 seconds in silence and reverence, because it's not happening again for quite some time here in North America. Okay, we hit the time. I did hear a telescope demonstrator say the word gone, which I think means you can't even see it through the telescope anymore. So we are so happy to have been able to bring you this live stream. I think for grins, Matthew, let's put up those timestamps again. Oh, okay. Then let's just put up the one timestamp, and that will permit our students to. Oh, I think we're about to get some movement of our dome. Yeah, that is the sound of the dome moving. There we go. Now we've got the timestamp up. As you can see, it's 18:05, so we are well beyond the end of our transit. And so let me, why don't we prepare, Matthew? We can come back to us so we can say goodbye, and thank our viewers for joining us. And okay.
So, Mom, were you with us the whole time?
All 4 hours
All 4
through the
hours.
clouds. Okay, as you can see, they moved the dome. I'm in full
You're in
sun
the full
now.
sun. We could scooch here
What
to the
happened to
left.
those clouds? I need some of those clouds.
You scoot
Yeah, I
towards
think I
us
will
this
scooch
way,
a
we'll
little
all-
bit this way. That's a little rough after being up at such a large fraction of the night. There we go. Ooh, that's better.
There we go.
So I don't know, Jared, if you can get all three of us, and you guys come on in. Come on in, why not? Everybody who's free, come on and stand behind us so we can say goodbye to everyone. Colin, that would be you. Come on, Colin, you worked this whole thing for 4 hours.
Come on,
Yep.
Katie, get on camera.
Yeah, Katie, get everybody here.
Brendan.
Be careful. And you know what? You too, Jared, because you just sat on this, I think.
All right.
Everybody's tuning out by now anyway, so come on, Katie, Gio, come. We're
You
ending
want to
our
see the
thing.
crew? Come get in here, Pinsky.
Fast.
We talk
Let's
about you
move
all
it.
the time.
All right. So,
I think he's got a 30-year wait.
yeah. Yep, there comes Gio. So behind me are all the people I mentioned earlier, thanking them, our telescope demonstrators. Why don't you raise your hands, telescope demonstrators, and our theater techs. Everybody smush in more, and then there we go. We're getting more of it. And we're all here in the telescope dome of Griffith Observatory. We all work here at Griffith Observatory. We're all thrilled to be part of Griffith Observatory. It's a beautiful place. And we certainly hope that you'll come and visit us here. You can always come the first Friday of every month, see All Space Considered. Come next Saturday for our celebration of Apollo 12 50th anniversary. If you go to our website, there are all kinds of events. We have a special program related to Chesley Bonestell coming up. We have star parties. We have all kinds of stuff. So come to your municipal observatory, Griffith Observatory, here to let you and the rest of the public look through telescopes and enjoy the heavens. We don't do research here. Our sole mission is to bring astronomy to the public. So that means you come on up, enjoy Griffith Observatory. So okay, we got the telescope demonstrators. Raise your hands again now that everyone's here. And theater techs, raise your hands and we can say thank to you. Thank you, theater techs. And guides, I think there's only one. David Pinsky, we show us stuff. Oh, who else? Oh, Jared, our cameraman whom we... And then Tony, Patrick, David, and myself, we all say thank you. Have a beautiful day. Enjoy your Veterans Day. Thank you to our veterans for their service. You give us the freedom to be able to enjoy a beautiful morning like this. So thank you to all. And with that, I think we're ready to sign out.